This really is example 3. Whoa, you can't see that. What is that? How about a color? 3.2. The previous video, I lied to you. Sorry about that. Didn't mean to lie, but I did anyway. This is actually example 3.2. In this one, we're going to take a look at subtracting vectors, the idea of a opposite vector and opposite vector. So let's take a look at that. Let's erase the problem number on there. Okay, so a woman sailing a boat at night is following directions to a dock. The instructions read to first sail 27.5 meters in a direction 66 degrees north of east from her current location, and then travel 30 meters in a direction 112 degrees north of east or 20 degrees west of north. So we're going all from 0 degrees all the way around past 90 to 112 degrees, which is 22 degrees west of north. That's what we're talking about. Okay. If the woman makes a mistake and travels in the opposite direction for the second leg of the trip, where will she end up? So she has a blonde moment. She drank too much coffee, got her Starbucks spilled in her lap. She made a mistake, went the wrong way. What happened? And what we're going to do is also compare this with where the dock is. Now, this could be really, really useful if you were out in the woods and you realize you went the wrong way somewhere or something, or even if you're out on a boat and you can backtrack where you went. So this is a very, very practical problem. A lot of this stuff with once we're starting to get closer to trigonometry is extremely practical. So let's try to do this in one take and one bit. So I'm going to draw, let's actually do our cheat and get at least our axes straight. Well, of course it's a little crooked, but it's at least straight relative to itself. Something. I don't know. So we'll draw that with that color, and then we'll have some other axes over here that we'll even change their color. Make these yellow. So, oh, that one's crooked too. Oh, well. It's going to drive those OCD among you slightly bonkers, and I'm sorry for that. But, you know, you'll live. I almost promise. Okay, so let's do it with the mistake first. We'll do the mistake on blue. Okay, so the first part of the journey is the same either way. So actually, we can go ahead and add that on both graphs. So the first part of the journey is 27.5 meters in a direction 66 degrees north of east. So 66 degrees north of east would be more than 45. So 45 is about right there. So it's going to be about right here. So I'm going to kind of put a dot and then connect the dots. If you're drawing this for real, you really want to use a protractor so you could, whoop, I can't even hit my dot right. That's what I get for using a tablet. Okay, so that's my first leg of the journey. This other one, it starts out the same way. So we'll do this lime green, the same idea because of the same vector. Then she has her blonde moment, right? And she's supposed to travel then in this direction to go, we're going to end up in the text, I'm sorry. I might be able to hide that in a second so you can see it better, but hang with me. She's going to go, she's supposed to go this way. So when we go in the opposite direction, we are only changing the direction. It's kind of a duh thing, right? But we're not changing the magnitude. So she's still going 30 meters, but in her broken state over here on the blue side, she ends up going, let's do bright red for mistake. She goes the opposite direction. So she would be going like this direction, but she actually goes this way. All right, so she ends up about right there. Again, you can use your protractor to find these distances good. You can use your ruler so that they measure out and the ratios are right. You can make it all pretty and such. So her displacement vector, let's make it orange because orange is kind of almost like danger. She's on fire. She ran into the flaming ship. This is her resultant vector. Her addition, you could also call it the subtraction of the correct one. So let's use some hot pink for the way she should have gone. So she should have gone this way. So you can see that her resultant vector, we'll draw this one in a nice pale soothing green, is her resultant vector is right here. So I can do this. I can use a tablet to draw a semi-straight line, something. All right, let me erase this text so you can see. So the way that she should have gone, she should have ended up way the heck up here. And she ended up way the heck down here. So when you subtract vectors, that's what happens. We end up with a totally different thing. So that's really all there is to it, because we're just doing graphical methods. In the next chapter, we'll actually use analytical methods and do the math. It's pretty simple, pretty straightforward. But for graphical addition or subtraction in this case, that's all there is to it. Catch you next time.